This video is to show the mechanism or explain what happens with mixed aldol reactions and show the mechanism for a couple of the products that people found confusing. So notice I have two different aldehydes here. One is acetaldehyde with 2 carbons and the other one is butanal, otherwise known as butyraldehyde, with 4 carbons. So when they react, we're going to call them A and B. Maybe not the same A and B I used on the Paradex slides, but A and B for this video. They're going to react and give us 4 products, AA, BB, BA, and AB. We're doing this to make sure everybody understands that BA and AB are not the same thing. So AA comes from acetaldehyde reacting with itself. BB comes from butyraldehyde reacting with itself, and BA happens when butyraldehyde attacks acetaldehyde, and AB comes from acetaldehyde attacking butyraldehyde. Because A and B have different numbers of carbons, the numbers of carbons in the different products will be different. AA has 4 carbons because 2 plus 2 is 4. BB has 8 carbons because 4 plus 4 is 8. BA has 6 carbons because the B from butyraldehyde attacked the A from acetaldehyde. 4 plus 2 is 6. AB also has 6 carbons, but they're arranged in a different way because in this case a different aldehyde acted as the nucleophile enolate. So now we're going to go through the mechanism of making AB. Here I have A and B shown, and I'm going to draw in the alpha hydrogen on A because it's going to act as the nucleophile here. And hydroxide deprotonates A to give us this enolate. So the A enolate attacks neutral B to give us a product that's an intermediate because it's an alkoxide. It's got the O on the beta position from the aldehyde. And you can see 1, 2, 3, 4, 5, 6. I have the atoms with the bond between carbons 2 and 3 because 2 attacked 3 in the reaction. The final step is the alkoxide reacts with water to deprotonate the water, and the alkoxide is protonated to form an alcohol. In this reaction, we must not have used any heat because we stopped at the beta hydroxy alcohol and aldehyde instead of going all the way to the dehydration step. All right, now I'm going to do the other possible product where B attacks A. So the first step is hydroxide deprotonating B at the alpha position. And now I have the enolate, only showing one resonance structure. This enolate reacts with neutral acetaldehyde to give us this alkoxide. And I've numbered my carbon atoms so you can see in this case it was a different attack. 4 attacks 1, and so the carbons are attached in a different order. And then the final step of the reaction happens when the alkoxide deprotonates water to regenerate hydroxide and to generate the new beta hydroxy aldehyde.